Download this code from codegive.com, link in the description below. Netflix is known for its highly reliable and scalable online services. Building stateful systems that can handle millions of users while ensuring high availability and low latency is a complex task that involves a combination of architectural patterns, technologies, and best practices. Below, I'll provide an overview of how Netflix achieves this along with relevant code examples. Key concepts in building reliable stateful systems. 1. Microservices architecture. Netflix employs a microservices architecture, which allows different parts of the application to be developed, deployed, and scaled independently. Each microservice is responsible for a specific piece of functionality. 2. Data management. For stateful applications, managing data correctly is paramount. Netflix uses various data stores, example Cassandra, MySQL, and caching layers, example evcache, to ensure data consistency and availability. 3. Resilience and fault tolerance. Netflix uses several patterns and tools to ensure the system remains operational even in the face of failures. The circuit breaker pattern and the bulkhead pattern are commonly used. 4. Load balancing. To distribute incoming requests evenly across services, Netflix uses load balancers, which help to prevent any single service from becoming a bottleneck. 5. Monitoring and alerting. Continuous monitoring of system performance is critical for detecting issues early and ensuring reliability. 6. Service discovery. Tools like Eureka help in locating the services dynamically, enabling services to find each other without hard-coded addresses. Implementation example. Let's create a simple microservice that simulates a user session in a streaming application. We will use Spring Boot for the microservice and Redis for session storage. 1. Setting up Spring Boot project. You can create a Spring Boot application using Spring Initializr. Include dependencies for Spring Web and Spring Data Redis. 2. Application properties. Configure Redis settings in the application.properties file. Properties. Spring.redis.host equals localhost. Spring.redis.port equals 6379. Spring.redis.password equals your password. 3. User session entity. Create an entity to represent a user session. Java. Import org.springframework.data.annotation.id. Import org.springframework.data.redis.core.redis hash. At Redis hash, user session. Public class user session. At ID. Private string session ID. Private string user ID. Private long last accessed. / getters and setters. 4. Repository interface. Create a repository interface for session management. Java. Import org.springframework.data.repository.crud repository. Public interface user session repository extends CRUD repository user session, string. User session find by user ID, string user ID. 5. Session service. Implement a service to manage user sessions. Java. Import org.springframework.beans.factory.annotation.autowired. Import org.springframework.stereotype.service. Import java.time.instant. At service. Public class user session service. At autowired. Private user session repository user session repository. Public user session create session, string user ID. User session equals new user session. Session.set session ID, generate session ID. Session.set user ID, user ID. Session.set last accessed, instant.now, .to epoch milli. User session repository.save, session. Return session. Public user session gets a Zion, string session ID. Return user session repository.find by ID, session ID, or else, null. Public void update session, string session ID. User session equals gets a Zion, session ID. If, session, equals null. Session.set last accessed, instant.now, to epoch milli. User session repository.save, session. Private string generate session ID. Return java.utility.uuid.random uuid, to string. 6 REST controller. Create a controller to handle HTTP requests for user sessions. Java. Import org.springframework.beans.factory.annotation.autowired. Import org.springframework.web.bind.annotation *. At REST controller. At request mapping, /API/sessions. Public class user session controller. At autowired. Private user session service. At post mapping. Public user session create session, at request param string user ID. Return user session service.create session, user ID. At get mapping, /session ID. Public user session gets a Zion, at path variable string session ID. Return user session service.gets a Zion, session ID. At put mapping, /session ID. Public void update session, at path variable string session ID. User session service.update session, session ID. 7 Resilience with circuit breaker. To handle failures gracefully, you can integrate a circuit breaker using Spring Cloud Circuit Breaker. Java. Import org.springframework.cloud.circuitbreaker.resilience4j circuit breaker factory. Import org.springframework.stereotype.service. At service. Public class resilient user session service extends user session service. At autowired. Private resilience4j circuit breaker factory. At override. Public user session gets a Zion, string session ID. Return circuit breaker factory.create, user session service. .run, -super.gets a Zion, session ID. Throwable -fallback method, session ID. Private user session fallback method, string session ID. // provide fallback logic, e.g. return a default session or throw an error. Return new user session. Conclusion. This tutorial provides a basic overview of how Netflix ensures high reliability in its stateful systems. By using microservices architecture, efficient data management, resilience patterns, and continuous monitoring, Netflix can handle large-scale user interactions seamlessly. The code examples illustrate how to implement a simple user session service using Spring Boot and Redis while also integrating resilience features. For production systems, Netflix employs many more advanced techniques and tools, like chaos engineering, advanced monitoring with tools like Atlas, etc., but this example should give you a good starting point to understand the principles behind building reliable online stateful systems. Sure. Let's explore how Netflix ensures reliable online stateful systems. Netflix, as a major streaming service, relies heavily on its architecture to maintain a seamless user experience, especially considering the vast amounts of data and user interactions. Overview of stateful systems. Stateful systems maintain a state across multiple requests from a user. In the context of Netflix, this can mean tracking user preferences, viewing history, and more. Ensuring reliability in such systems is crucial for a good user experience. Key concepts in building reliable stateful systems. 1. Microservices architecture. Netflix employs a microservices architecture, allowing different services to handle specific functions. This modularity enhances reliability, as failures in one service do not necessarily affect the entire system. 2. Data management. Netflix uses various data storage solutions to manage state, including databases, caches, and distributed storage systems. They often employ a combination of SQL and NoSQL databases to balance consistency and availability. 3. Replication and redundancy. Data is replicated across multiple nodes and regions to ensure availability. If one node fails, others can take over without downtime. 4. Circuit breaker pattern. This design pattern helps to prevent cascading failures. If a service is failing, the circuit breaker stops requests to that service until it recovers, allowing the rest of the system to function normally. 5. Asynchronous communication. By using message queues and asynchronous communication, Netflix can decouple services. This approach allows services to work independently, thereby increasing overall system reliability. 6. Monitoring and alerts. Continuous monitoring of system performance and health is critical. Netflix uses tools like Atlas, their real-time telemetry system, to monitor and alert on system health. 7. Graceful degradation. In case of failures, Netflix designs systems to degrade gracefully, ensuring that users can still access some functionality instead of facing a complete outage. Code example: circuit breaker pattern. Here's a simplified code example in Java using the Netflix Hystrix library, which implements the circuit breaker pattern. Maven dependency. First, add the Hystrix dependency to your pom.xml. XML. Dependency. Group ID com netflix.hystrix/group ID. Artifact ID hystrix_artifact ID. Version 1.5.18/version. /dependency. Circuit breaker implementation. Here's an example of a service that fetches user data with a circuit breaker. Java. Import com netflix.hystrix.contribution java nica.annotation.hystrix command. Import org.springframework.stereotype.service. At service. Public class user service. / simulate a method that fetches user data. At Hystrix command, fallback method equals default user. Public user get user data, string user ID. / simulate a call that may fail. If math.random 0.5. Throw new runtime exception, failed to fetch user data. Return new user, user ID, John Doe. / fallback method. Public user default user, string user ID. Return new user, user ID, default user. Explanation of the code. 1. Service annotation. The at service annotation marks the user service class as a Spring service. 2. Hystrix command. The at Hystrix command annotation wraps the get user data method. If this method fails, throws an exception, Hystrix will invoke the default user method as a fallback. 3. Fallback mechanism. The default user method provides a default response when the primary method fails, ensuring that the application can still return a response even in case of a failure. Conclusion. Netflix employs a variety of strategies to ensure the reliability of its stateful systems, ranging from architectural patterns to operational practices. By leveraging microservices, circuit breakers, and asynchronous communication, Netflix can deliver a highly reliable service to its users. The circuit breaker pattern was shown in the code example to illustrate how you can handle failures gracefully, ensuring that the system remains robust even under stress. This tutorial provides a foundational understanding, and there's much more to explore in the realm of stateful systems and microservices architecture.